Gemini has Castor and Pollux. Castor is actually 3 pairs of binary stars, so there are 6 of those. Pollux is actually a red giant on its way to becoming a white dwarf. And in this constellation is Gemini, which is a pulsar. Now, last year, of course, we had the Crab Nebula and the Crab Pulsar, so I'm sure many of you watched the movie clip on the Chandra website for the Crab Nebula. It's really pretty stunning. It's actually better than this one, but you can see that this has sort of the same structure. You can see the shock wave, the pulsar itself is in the center. It's surrounded by an accretion disk. There's a shock wave moving through that disk. You can see a little bit of a jet on it, but what makes this one rather unique is that for some reason it seems to be producing an awful lot of gamma rays. So it's kind of a mysterious pulsar with not a lot known about it. Hydrus is also in the southern hemisphere, not to be confused with Hydra, which is the snake in the northern hemisphere. Hydrus is the lesser, known as the lesser snake, and Hydrus is bordered by Doradus and Mensa, 2 constellations on the left that include the Large Magellanic Cloud. And the Large Magellanic Cloud is mostly in Dorado. A little bit of it slops over into Mensa. And then on the other side of Hydrus, we have the Tucana constellation, which includes the Small Magellanic Cloud, but actually a little bit of the Small Magellanic Cloud also slops over into Hydrus. So, but mostly the Small Magellanic Cloud is considered to be in Tucana. In Hydrus is NGC 602, which is called the flying lizard, and you have to see an image of it from far, far away to see that it does sort of resemble a flying lizard or something flying. And in the center of it, there is a really nice open cluster of stars. Again, this is a Sirius star formation region. The radiation from these forming clouds has triggered a progression, a really nice progression of star formation. So this is a very well-studied nebula for determining how stars start the formation of other stars. Leo has Regulus, which is a B main sequence star, part of a 4-star system. It's a 4-star system, but kind of a weird one. It has it's a double star system, orbiting it like as far away from Regulus as Pluto is from the sun. There's a double pair orbiting that far out. And then at the distance between Mercury and the sun, there's a white dwarf orbiting it. So 0.4 AUs is a white dwarf, and at almost 4,000 AUs, there is a double system orbiting it. Lyra, the harp, of course, has Vega, which is the 3rd star that is part of the Summer Triangle asterism. It contains M57, the Ring Nebula, again, a planetary nebula with a white dwarf left behind. So this started as a sun-sized star, evolved to the red giant stage, and is now at the planetary nebula white dwarf stage. Now look at this one again. That is the usual image you see when you see the Ring Nebula. Here is another one that looks very different, and you would never think this was the Ring Nebula, actually, if you just looked at it. Another reminder that you need to know these objects at different wavelengths, because they look very different at different wavelengths. This one happens to be a composite of both optical and infrared from 3 observatories. One is Hubble, one is the Large Binocular Telescope, which is on Mount Graham in southeastern Arizona, and the Subaru Telescope, which belongs to Japan, which is located at the top of Mauna Kea in Hawaii. So again, it looks very, very different. So make sure that you see these deep sky objects and study them in all wavelengths. Ophiuchus is the serpent holder. It is now, and it has a star, Zeta Ophiuchi. Zeta Ophiuchi is a main sequence star. It is a 9.5 classification. Now, for masses of stars, there are almost no O-type stars. Only a small handful. Maybe half a dozen are known. That's huge. It's almost a B because it's a 9.5, but this is a huge, huge star. And it is a main sequence star. It is located right there at the bottom part of Ophiuchus. And it is also very strange in that it is thought that it had a companion star that went supernova, and these must have been fairly close. It must have been a massive supernova, and it just flung this star totally out of the system. So it is now plowing through space-time, plowing through the interstellar medium at 24 kilometers per second, and producing this big bow wave in front of it as it moves through the interstellar medium. It's 20 solar masses, 65,000 times more luminous than the sun, and it is already halfway through its lifetime, because if you are an OB mass star, your lifetime is only 10 million years. 8 million. This one is 8 million years. So it's already one halfway through its lifetime. In Ophiuchus is Kepler's supernova event. And just like Tycho's supernova event, Kepler's supernova event is also a type 1a supernova event, the thermonuclear destruction of a white dwarf. And once again, if you look at the difference, if you look at the Hubble image of that part of the sky, you see nothing but stars. And if you look at it in X-ray, you actually see the supernova remnant because it does not produce optical wavelengths. This is a composite image of Kepler. Chandra data is in blue. The Spitzer infrared data is in red. And the two of them have both wavelengths observe a kind of a disk structure in the center of the Kepler supernova remnant that is thought that it was caused by the previous material that had been thrown away from the star and then was run into by debris when the explosion actually occurred. So again, this is a fairly new finding, I believe, or release. So a lot more will be known about that eventually as people analyze the data even more. Orion with Betelgeuse, which is an M-class star, so it's very cool. Its luminosity class 1 is very luminous, way up there. And Rigel, which is a B massive star, it's also very luminous. It's also luminosity class 1. So things are going on with these stars. They are no longer on the main sequence. They are evolving. Betelgeuse is more evolved than Rigel because it is an M now. It's cooler. Rigel is a B, so it has left the main sequence, but it hasn't evolved too far yet horizontally on the HR diagram. And as we all know, in the sword hanging from Orion's belt, that middle star is not a star, but is M42, the Orion Nebula. And this, just to show you that if you look on this luminosity class, we have Betelgeuse, which is an M. We have Rigel, which is a B. And when you go up and look, you can see that B star luminosity class 1 still is just left the main sequence not too astronomically long ago. And you can see that Betelgeuse is well evolved towards its ultimate collapse. Here are different images of M42, the Orion Nebula. No change in this graphic from last year because again, you have to know these deep sky objects in more than one wavelength. We have on the left-hand side, we have two astrophotographs from ground-based observatories. And because this is only 13 to 1,500 light years away, so it's pretty close. So you can get some really high-resolution, detailed images from ground-based telescopes. And then on the right-hand side, on the top, there's Hubble, and it shows that bright area in the low, just below the center, that is called the trapezium, and this is where star formation is taking place. And below that, you see two images, Chandra X-ray and Hubble, which is a close-up of that trapezium area. Now, these are the exact same scale. The Chandra X-ray and the Hubble image in the lower right-hand corner are the exact same scale. Hubble sees what is producing optical wavelengths. Chandra is seeing what is producing X-ray radiation. And so you can see what a huge difference and how much more you can see if you're looking at an object with a specific wavelength.